So hello everyone, this is Akshay here, and let us start with the next question of our binary tree section. And I have updated the my recursion playlist, so you can always access this SD sheet link here, and you can navigate through all the question. And if you are new to this channel, please like, share, and subscribe so that you can learn, maintain, and grow. So ठीक है. So how the in-order traversal is done? That we have given a tree and you have to do the traversal. That is, you have to traverse each and every node in a particular manner. The in order says that you first have to traverse in the left subtree, right? You have to call a recursion. I've already explained you what the recursion is. So you have to recur for the left part, then you have to visit the root element, and then you have to recur for the right subtree, right? So if I do the recursion steps here, let me write the pseudo code for you guys, and then we will do the recursive steps. Okay, so that would be the pseudocode. And if I run the pseudocode on this tree, what would be the output? So first we have to come at the root node, right? And then you have to traverse left. You have to keep on traversing left until you hit a null pointer. So if you hit a null pointer, then you have to return back. And before returning back, after returning, the call goes to its parent, and you have to print the data. So first, where 40 would be printed. Then what you have to do, you have to access the root data, right? Okay, so 40 is done. So the left is completed. For after the left, we have to access the root, and then after the root, we have to access the right. So 40, 20, right? The root of the parent of the 40 would be 20, and then 20 in 20 you have to move in the right subtree, right? So right subtree from 20 I come to 50, and then 50 again I have to recur for left, right? So the 70 will be printed, and then the root data, like the parent of 70 would be 50, and then I have to recur for the right subtree. So in the right of 50, nothing is there, only 80 is there, so we don't have to recur for left as well now, so it would be 80. Now whole the right subtree has been, the left subtree had been completed. Now the root data would be printed, and then you have to compute the right subtree, right? So from 10 I come to 30, and I can see there is no left child, right? So I will then return back and I will print 30 there, right? And then I will recur for the right subtree, and in the right subtree I will again see that my left is nothing but pointing to null, so I will again return back to my parent, and 60 would be printed. So this would be the in order traversal of this particular tree, and that's it, the pseudocode there, right? Okay. Okay, so let me tell you the recursive flow as well. So first the function of 10 will be called, and then the subsequent f of 20 will be called. Then again we will recur to the left subtree until and unless we hit the null. So f of 40 will hit the null pointer, right? And if the null is there, then you have to return. So there were three statements to execute for a particular node, right? So first we return, and then what happens that we have to print this particular data. So I will say p of 40, like print 40, right? And then recur for the right subtree for this 40, and there is nothing in the right of it's null, right? So again it's return. So 40, f of 40 has been now completed, so f of 20 will happen now. In f of 20, so first of all the call has been recurred to 20, and the second when for when we were at the 20, we completed the left call, and the second statement was to print the root dot data, so it will print 20, and then when it will recur for the right subtree, right? So when it will recur for the right subtree, that means what will happen in the right, f of 50 will be called, right? And then f of 50 will again call for the left hand child, that is f of 70, right? And f of 70 again it goes to null, and it hit f of null, and it returns from here, right? Similarly the second statement will be executed of print 70, right? And then it will call for its right child, and then the right of 70 is again null, and it will return, right? So now the parent call come back to this 50, and it will, the second statement execution was of print 50, and then it will call for its right subchild, that it is called the function of 80, right? So it will again hit for the left child, that is null, and it will return from here. It will execute the second statement, that is print the root dot data, and then it will call for the right child, that is again it's null, and it will return, right? Now the call comes back to this thing. So now what happens that all the left subtree of this f of 10 has been done. Now the second statement will execute, that is print 10, and then it will call for its right child, and the right child is nothing but f of 30 will be called. Again f of 30 will call for its left child, that is f of null, it will return. The second statement of to print the 30 note, the root dot data, and then it will call for its right child, that is 60, right? 60 will again call its left child, that is f of null, and it will return from here. Again, the second execution statement is nothing but the print the root dot data. So it will print 60 here, and then it will call for its right child, that is f of again null, and it will return from here, right? So what is the sequence of the statement that is getting print? So this is the first, that is the first, what was print? This was the first print, this was the second print, this was third, this was fourth, this was fifth, and then this was sixth, I guess. Yep. And this was seventh, and this was eighth, and this was nine. And you can see this is the sequence of the in-order traversal that we have done, right? Okay. Yeah, so actually the function is called here. So 4, this is fifth call, this is the fifth print, and this is the sixth print, and this is the seventh print, and this is the eighth print, right? Okay, so and this is the same, we have returned our output. That would be the pseudocode. Now I hope you have got a very good grasp of how the in-order traversal is done, but it is recommended to please try for some of the trees as well by yourself. Okay, so please pause this video now and do the in-order traversal for this tree, right? So I hope you are able to do it. Now let us do it together. So first the root node will be here and it will recur for left. So 10 to 20. First 20 will be printed, then the root node will be printed, and then it will again call for its right child, but then again the left child exists, right? So third, it goes to 40 and then the root and then 10. So this would be the in-order traversal for this particular tree. Great. Okay, so let us jump back to the code now. So that's the GFG problem mentioned here, that to find the in-order traversal of its, and we have this as class solution, and the return type is array list, right? So we have this in-order code here, right? But in the function parameters we need to pass the array list as well, because the return type is array list, right? And at the same code we made up array list, and then we call this in order, and we just return the array list. And in the in order, what is happening, that if it is null, then we are returning, else we are calling for the left subtree, then we are printing the data, and then we are calling for the right subtree, right? If you hit the submit button, it will definitely get submitted. And what is the time complexity of this code? That we are visiting each and every node once, so it would be O of n, and O of height of the tree will be the space complexity. Why I'm saying that O of height of the tree will be the space complexity? Because in a recursive stack, what will happen, that first your 10 will be get stored, then 20 will be stored, and then 40 will be stored, right? Then 40 will be popped out, so that the call goes to its parent, that is 20, and it will recur for its what, right child, right? So you can clearly see that the maximum space this recursive stack is holding is the height of the tree, right? So 50, then it will again, you will say that the recursive stack will have 70. So O of 4, and you can clearly see that the height of this tree is 4, right? So I hope we have a good grasp on why the space complexity O of height of 3 and why this time complexity O of n. Similarly, you will have a Leetcode question here as well. The number is, I guess, 94, and the same code can be run here. You can submit the solution and you can verify it, right? Okay, so all the test cases have been passed. So let us end this video, and we will meet again in the next video of pre-order and post-order traversal. So thank you. Till then, keep learning, keep going. Bye bye, and take care.